Hey everybody, I'm Matthew Christopher from Microsoft, and I'm here to talk about how we are collaborating with Crossplane to do Azure Service Operator and Crossplane code generation for Azure resources. So what are we going to talk about today? First off, we're going to talk about Azure Service Operator versus Crossplane. What are the similarities? What are the differences? Why are there two? Then we're going to move on and talk a little bit about Azure Resource Manager, otherwise known as ARM. We're going to talk about the code generation work that we've been doing for Azure Service Operator over the last couple months. And then we're going to dig into how we can use that code generation not only for ASO, but also for the community and Crossplane to generate resources for Azure as well. Finally, we're going to talk about the current status of that work, how it's integrated with Crossplane today, and what the next steps are to finish that integration. So first off, a question we get quite often, what's ASO versus Crossplane? Like, when should I use one versus the other? What are the differences? So we really think about ASO as this infrastructural building block. It's meant to be a low-level way to manage your resources in Azure through Kubernetes. It matches existing Azure resource shapes quite closely. It matches Azure API versions quite closely. So you can think of this almost as like the low-level SDK that we're trying to target for managing your resources in Kubernetes. That sort of stands in contrast to Crossplane, which certainly supports doing a lot of those same things, but the focus with Crossplane has always sort of been more, I want to call it high level, where it's supporting uniformity across different cloud providers, uniformity of secret management, uniformity of cross-resource references and ownership. It's modeling and managing groups of resources with composition, right? This notion of composition is really a higher level concept that Crossplane enables. That's not something that ASO does, and it's not something that ASO strives to do. So that really is the difference between ASO and Crossplane. So let's talk about where there's similarities between the two projects, where we could maybe share some development effort. And not only could we actually have been sharing some development effort. So there are thousands of developers at Microsoft working in Azure, and they're all producing new resources, modifying existing resources, adding new services. How can the community possibly keep up with the rate of development of Azure? It's so fast. It would be great if we could come up with some sort of solution that let the community benefit from the speed that's, all of the new resources in Azure, but they don't have to write everything themselves, to call the API through Kubernetes. And so this is where it makes sense to collaborate between ASO and Crossplane, because we've got exactly the same problem in ASO. So let's talk about the beginnings of a solution. I mentioned that Azure Resource Manager has this thing called ARM, and it turns out that all of the interesting resources in Azure, maybe not all of them, but 95% of the resources in Azure go through the ARM interface. And they actually have a common shape. They've got a location, they've got name, they've got tags, etc. And ARM defines this generic API, which is the deployments API, for doing CRUD operations on any ARM resource. All you need to know is what the shape of that resource is. So, a Redis looks like this, a SQL Server looks like that. This is really powerful, but obviously has the downside that, you still need to know what the resource looks like. And obviously every resource, even though they do have some commonalities, location, names, tags, etc., there's a lot of differences too. But it turns out that this is actually a solvable problem because Azure defines an open API specification for every single service. So the combination of these two things starts us down a path where, hey, maybe we could use those open API specifications. We could generate something with them that lets us do management through this generic deployments API, and that way you don't have to write, an SDK call for every single CRUD operation you want to do. You can do it all generically. And it turns out that this is something that Azure has done before. because all of the SDKs are already generated from the existing OpenAPI specifications. So this is a road that we've traveled before with respect to how can we scale out to match the size of the cloud. And the answer is with some code generation. So talking just a little bit more about Azure Resource Manager, because it's an important piece of the puzzle. Already today, Azure Portal, Azure PowerShell, Azure CLI, the SDKs, the REST clients are talking to ARM. So what we're really thinking about or talking about here is, what if we had another box that was up at the top of this diagram that also was talking to ARM, and that box was Kubernetes CRDs for Azure. And so that's what we've been working on. We've been working on a code generator that can do exactly that. Take these OpenAPI specifications, the knowledge of what the deployments API is, and generate the CRD YAMLs that can be used to provision Kubernetes types and manage them in Azure. So digging into that process a little bit more, the interesting bit is actually not getting to the CRD YAML, because there's already an open source tool, KubeBuilder, that can go from Golang types with KubeBuilder annotations to CRD YAMLs. So rather than try and reinvent the wheel for getting all the way to the YAML phase, we figured it makes more sense, let's just use this open source tooling that is industry standard. Crossplane is also making use of KubeBuilder. Let's just use this, and what we really need to do is get from up here, these Swagger types, these OpenAPI types, to Golang types with KubeBuilder annotations. So how can we do that? Well, what we've done is we've created a code generator that has a pipeline of steps. At the top, it reads in the OpenAPI specification. It builds an in-memory representation of it. It adds some Kubernetes-specific fields, stuff like spec and status. It adds some ASO-specific fields like owner, Azure name, that sort of thing. And as we were getting into this effort, we realized, hey, a lot of this can be shared with the community and, for example, Crossplane or any other operator that wants to generate CRDs for Azure. And so we've been collaborating with the Crossplane developers, trying to figure out, well, how much exactly is shared, and how can we leverage this shared effort to solve both our problems and make the development experience in ASO and in Crossplane better for everybody. So let's actually, before I get onto this, go talk a little bit about and show a little bit what I mean by there's a lot of similarities between these two phases. So here is the core pipeline, we call it, for generating Azure Service Operator resources. And you can see right at the top here, we're pulling information in from Swagger. So this is sort of the beginning of the pipeline. We've just read stuff in. We're building our in-memory model. Then we're giving types some names. We're determining resource ownership, what resources own what other resources. We're creating storage types. We're simplifying definitions. We're marking storage versions. And then at the end, we're going to output the Go types with KubeBuilder annotations. So this process, there's a little bit of stuff that's Azure Service Operator specific here. It kind of comes in here, like this Kubernetes resource interface, that's ASO specific. And these ARM types are a little bit ASO specific. But if I come down here, we've actually now got a Crossplane pipeline stage as well. And hey, look, it's very similar. All of this is basically identical to what we're doing for ASO. So the only difference is, instead of doing those ASO-specific property mutations and additions, we're going to do some Crossplane-specific property mutations and additions. So it's just this little bit here that ends up being different between the code generation process for Azure resources in the Azure Service Operator and in Crossplane. And that's actually really great, because that means we've just shared a ton of development effort and solved or at least are beginning to solve the problem for everybody. So let's talk a little bit about what OpenAPI doesn't give us, because it doesn't give us everything. It doesn't do anything for us for authentication. It doesn't do anything for us for a notion of Kubernetes ownership or cross-resource references, and it doesn't give us any error handling. So even though OpenAPI solves a lot of our problems with regard to understanding what the shape of resources are, we still need to do the work to write the controller that understands, well, okay, my deployment of a resource failed. What do I do? Right? What's the next step? And we need to have some way of mapping ownership in Kubernetes into ownership in Azure, because it's not obvious from the OpenAPI specification how to do that. So that brings us to the current status and next steps. I mentioned that we've been collaborating with Crossplane for a while, and there's an open PR in Provider Azure that's a showcase of Azure resources being generated by this code generator that I've just showed you. So it's not generating everything, and there's still some work that needs to be done to clean up the type structure of the generated resources. So, we aren't at the end goal yet, but we have made some pretty good progress. So let's go take a look and just see what those resources look like. So I mentioned Redis a little bit earlier, and here is a Redis type. So Redis in Crossplane has a spec and a status. Okay, that makes sense. The spec has for provider, which is the standard shape of resources in Crossplane, and then this Redis parameters has the information that would be conveyed to the cloud provider, which is Azure. So if we come down and take a look at this code-generated Redis parameter struct, okay, it's got a location, it's got a name, it's got a resource group which it lives in, it's got zones, it's got tags. So this looks pretty good. This looks pretty reasonable. Obviously, there's a few things that aren't perfect about this. Okay, hey, maybe we need to get rid of this property. Maybe we need to clean a few other things up. So not everything is done yet. And the other thing that still needs to be done with the integration with the code-generated resources in Crossplane is we've been talking about that deployment API that ARM supports, the generic way to manage resources. So we need to come up with a way to use that API but plugged into Crossplane's existing interface. And that's something where, since we already are using that API in Azure Service Operator, the avenue that we're investigating right now is, hey, maybe we could take what we're doing in Azure Service Operator, make it a little bit more generic, pull it out into a shared library, and then we can use that same shared library in ASO and Crossplane, and that can be another place where we've then deduplicated development effort. So that's the current status of the code generation effort in Azure Service Operator and how it's being used in Crossplane as well. We're really excited to be collaborating with the Crossplane developers, and this is a great opportunity for us and Crossplane to sort of stop having to do some of this manual work. That's everything that I have. If you have any questions, please feel free to ask. Thanks.